we got the equation solved as this equation last class. And the big thing to look for a hyperbola is a minus sign. That's the only difference between an ellipse and a hyperbola is a minus sign. And I'm just going to go through this one with you since Monday. But the first thing is to identify your transverse axis. So like the more important axis, kind of the major axis. That's based on what comes in front of the minus sign, right? So if the y is coming first, that's telling you that you have a vertical transverse axis. So your hyperbola is going to look like this. It's going to open up and down. That's what a vertical transverse axis tells you. You can identify your center. So the x value goes right 1 and the y value goes up 2. So 1, 2 is our center. So I can plot 1, 2 on the graph. And then you want to identify A, B, and C. I'm not going to have you, maybe I will have you graph the foci. So I would have to put this equation as a formula. So I'm just going to add over here. So hyperbolas, the asymptote, and the foci, and we'll put c squared equals a squared plus b squared given. So that's another formula. So, I mean, to me, it's too many different letters. So I would give you the formula, the c squared equals a squared plus b squared. A is the denominator of the first fraction, but I have to take the square root to get a. So the square root of 4 is 2, and b, the square root of 9 is 3. So in the vertical direction, I'm going to go up 2 and down 2. And I'm actually going to write a V next to them because those are actually my official vertices. So hyperbolas, they only have 2 vertices. Ours are going to go in the vertical direction. So like here's the actual vertex of each part of the hyperbola. And then you're going to walk 3 units to the right and to the left. 1, 2, 3. And that would have been your ellipse if this had been an ellipse. But we're going to box them in using a rectangle. And this is going to be the framework for our hyperbolas. Once you have your rectangle, remember you dot in the diagonals of the rectangle. So it goes through the center and through the corners of your box. So you draw in your diagonals, which are the asymptotes. I'm just going to do mine in a different color to emphasize. Now you finally are drawing the actual hyperbola. So the hyperbola touches the vertex and then goes out towards the asymptotes. Doesn't go inside the box at all. It just touches the vertex and then goes out towards the asymptotes. So the green is the only part that's the actual hyperbola. Everything else is the framework. People kind of remember that from Monday, hopefully. We're going to have more practice on hyperbolas in a little bit, after we do notes on parabolas and walk for a couple minutes. So now I'm going to solve for the C value. Where do those focal points go? So let's see. We know a squared is 4, and we know b squared was 9. 4 plus 9 is 13. So C is going to be the square root of 13, which I think I need a calculator for. 13. Square root of 13 is what, 3.6? So 3.6 is the distance I go from the center out inside the hyperbola. 1, 2, 3.6 is right here. 1, 2, 3.6 is right here. So there's my focal points. So remember the definition of a hyperbola, it's the set of all points and the difference in the distance from this focal point to this focal point will always be the same. So if the difference is always 6, if this is 3 and this is 9, the difference would be 6. The difference is the same. And then the asymptotes. So we talked about why point slope form is helpful. I don't know that exact y-intercept, so it makes slope intercept form hard. How do I write the equation of those asymptotes? So we defined point slope form as if you know a point on the line, x comma y, and you know a slope of the line, you can write the equation of the line. The asymptotes share the center point because that lies on both of them. So to write the asymptotes, I can kind of steal it from the equation, right? Y minus 2 equals plus or minus the slope. What do I go? Up 2 over 3, 2/3. And I'm going to kind of steal this x minus 1 from the equation because that goes right 1 and that goes up 2 to the center. So this is called point slope form. I know you haven't probably seen that, some of you, since Algebra 1 maybe, but that's how you write the equation of those asymptote lines. So like one example, not this step, but from this step on will be like part A of a question on Friday. So like question number 3 will be graph these conics, and I'll give you one that's a hyperbola, and you'll have to go through these steps, and then one that's a parabola. And that will be one question out of like the maybe 5 or 6 questions. How many bullet points are up there? 6. Like about a 6-question summative. I like to do part A, part B, so I can give you a rubric score, just like I did on the quiz, like 5, 4, 3, 2, 1. All right, so a parabola. So we're going to talk about the parabola, and then we'll take a stretch break, and then you can come back and do some practice on that 407C. We don't have to finish all of 407C today. We have some time tomorrow too, but all right, so a parabola now is a set of points that are equidistant from a fixed line called a directrix and a fixed point called a focus. So this distance and this distance are the same as each other. And then as I move out, now this distance and this distance have to be the same. And also this distance right here, when it's right on the vertical line, and this distance right here have to be the same. That's actually called the P value of the parabola. So I'm going to show you what that means in a minute, but you've got a focal point that you're opening around. You have a vertex of your parabola. You have a directrix. If you did like standard form, you'd get the same graph. This is just going to be in a slightly different form than what you've seen for parabolas before. Next unit, you're going to review standard vertex and intercept form of a parabola. So just kind of take this as this is conics form. So if it has a vertical axis of symmetry, see how this has a vertical axis of symmetry? I'm just going to draw that it looks like this. A vertical axis of symmetry, the equation is going to be x minus h squared equals 4py minus k. H and K are doing the same job as in all 3 of the other conics. They always tell you your left, right, or your left, right, up, down for your center. How can I tell that this is a parabola and not a circle, ellipse, or hyperbola? Only one of the terms is being squared, x squared. In this one, it's only going to be y squared. So if one of the terms is a square, you're back to a parabola instead of circle, ellipse, or hyperbola. And then the 4p value tells you 2 pieces of information. If p is positive, you have a concave up parabola. And if p is negative, you have a concave down parabola. And 4p is the focal width. And I'm going to show you what that means when we graph it. But the focal width of a parabola is this distance right here at the focus. And those of you that are doing like graphics with a camera, I'm pretty sure focal width translates to like camera terminology too. But the focal width, how wide that opening is 4p. So that is 4p. This is p, and this is p. So the distance from the vertex to the focus is p, and vertex to directrix is p, and then 4p goes all the way across. So basically, That gives you all the key points that you need to know for your parabola. You don't have to do the key points like we did in algebra 2, like over 1 up 1, over 2 up 4, over 3 up 9. Maybe that sounds familiar. The other orientation you might see is horizontal. So that's why I like to show students parabolas, just to get out of the traditional parabola. Hey, you can also open sideways if your y is squared. We just didn't graph them with functions because they're not a function. Oops, I should say x. And I will put the parabola in one of these two forms for you, so you won't have to translate it into conics form. So there's no real equations I need to give you, I think, for parabolas. Just if you have the formula, how do you graph it? If p is positive this time, you're going to open sideways to the right for positive, and if the p-value is less than 0, negative, it's going to open to the left. So right for positive and left for negative, just like up or down, kind of concave right or concave left. I think right in my head, I think positive. So I think that should be okay to remember. All right, so here's one that they're giving it to you in graphing form. It's ready to go. So I should be able to identify a lot of pieces of information from just this equation. First of all, I'm going to skip this directrix question first. Let's talk about axis of symmetry. How is this going to open? X is being squared. So this is going to be a parabola that just opens up, right? So it's going to have a vertical axis of symmetry, which makes its directrix go in this direction. So the directrix is going to be horizontal then. So if the axis of symmetry is vertical, the directrix is going perpendicular to that. So vertical, horizontal. The coordinate of the vertex, I'm going right 3, up 0. So 3, 0. This is asking you for the p-value. The 4p value is 8. So if 4p is 8, then p by itself is just 2. Make sure you do that math. I'm going to answer this equation and coordinate at the end after I've graphed it. So I'm going to go to 3, 0 and put my vertex. There it is. And I already know it's going to be going like this, right? Concave up parabola because p was positive, x is being squared. I have to use that p-value a couple times. So if I go up 2 units, that's my focal point because p is 2. And if I go down 2 units, that's my directrix. So now I know the position of the focus and the position of the directrix. So I can fill in this information. The directrix is the horizontal line at -2. So y equals -2 is how to write a horizontal line. The coordinate of the focus, we're at 3, 2. Right? That's the point 3, 2 right there. I just have to figure out how to graph the wideness of this parabola. Excuse me. Remember I said 4p is 8, and that will be the focal width. So you're going to go 1, 2, 3, 4 on either side, 1, 2, 3, 4, so that the total focal width is 8 units wide. So those are the key points of a parabola in conics form, which I think is just kind of interesting and different. You've been so ingrained to do standard form, vertex form of a quadratic. Here's another way that you could be given the information of a quadratic. Just something else to think about. Since we haven't reviewed quadratics, maybe this is easier to just kind of go first, a new way to graph quadratics. All right. So I just put kind of 2 more examples. Here's another one when x is being squared. So I'm going to still walk through it with you, and then we have some practice to do on our own when we come back. But x is being squared this time, and it's a negative p-value. So I just like to kind of sketch what is this going to look like at the end. It's going to be a concave down parabola. So what does that tell me about the directrix and axis of symmetry? Well, here's my axis of symmetry, and here's going to be my directrix up here, right? It opens away from its directrix. So my directrix is going to be horizontal. You know how to remember horizontal, right? Like the horizon, the sun comes up over the horizon, horizontal. And then axis of symmetry is going to be vertical, cutting that in half. Coordinate of my vertex, I'm going 0, down 3. So 0, comma, -3 is my vertex. It's going to look like this, right, from here. So just keep this in mind the whole time. What's the end result look like? Concave down parabola. The p-value. If 4p has to be -16, p by itself is -4, and the focus goes inside your parabola. So I'm going to go down 4, 1, 2, 3, 4, to plot my focus, and the directrix is above it. So I'm going to go up 1, 2, 3, 4, and there's my horizontal directrix. And then to graph the parabola, okay, equation of directrix. Y equals 1, right, is that horizontal line. And what is this coordinate? I just went down 1, 2, 3, 4, 5, 6, 7 units, right? So 0, -7 is the coordinate of that focus. Then the last set of key points, you want it to open up 16 units across its focal width. So that means going over and dotting at 8 on either side. This is a 10 by 10 grid, so you could just go almost all the way to the end if you don't want to count them, 2 away from the end. So this is a pretty wide parabola. And if you think about, if you were going to put this into like standard form, you would divide through by 16. So your A value is 1/16. Think about how shrunken of a parabola that is. That's what's making it so wide. Think about standard form of a parabola, right? 1/16 as an A value, if I divided through, would be pretty small, right? So that's why it's so wide. So we'll do number 3, and then we're going to take a stretch break, because this is hard stuff, right? It's like, blow your mind. I've never seen this before. I think that's kind of cool, because so far in, I feel like Algebra 2 is a review of Algebra 1. It's kind of nice to do something just new, mathematically, stretch that brain to grow. All right, so the y is being squared this time. So ding, 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 this is a sideways opening parabola. I've never seen this before, right? It's a negative p-value. So in your head, you're thinking leftward opening parabola. So y squared is left or right. The -4, I'm opening to the left. So that makes my directrix this time vertical and my axis of symmetry horizontal. So they flip-flop. Directrix is vertical, axis of symmetry is horizontal. I can find the coordinate of my vertex. X is not going left or right, and y is going down 2, right? So 0, -2. 0, -2, you can plot as your vertex on your graph. And just keep in mind, we're opening to the left. So from this point, it's going to be that sideways parabola opening to the left. My p-value. So if 4p is -4, when I divide by 4, p by itself is just -1. So you need that p-value by itself because that's how much you're opening with your vertex, or from your vertex to your focus and your directrix.